Yes. Good evening, students.
Good evening, sir.
Yeah. So
Good evening, sir. You can start now, sir.
yes, madam. Yes, madam. Now, in the last class, we have analyzed the concept of the ray optics, right? So in the today's session, we'll take up the concept of the wave optics. Let me give the complete concept of the formulas and the concept behind this. That is wave optics. So in this wave optics, we are going to study the light. We are going to study the concept of light here by considering what type of nature? A wave nature. And in the ray optics, you have analyzed the concept stating that I is equal to R, and also you had proved that Lenz's law, that is N is equal to sine I by sine R. So you have studied this laws in the ray optics, but you have not studied the proof for this. So we cannot give the proof for this too by using the concept of ray. So in the ray optics, we have not studied any proof of this. Just we have taken as the laws by stating that I is equal to R or N is equal to sine I by sine R. But you can ask why you have to take I is equal to R, and you can also ask why N is equal to sine I by sine R, and why always light travels along a straight line with an arrow mark, which is going to be a straight line direction. All this can be explained. All this phenomenon can be explained by considering the light as which type of nature? Wave nature. Actually, wave nature proves all the concepts of ray optics. And this wave theory first was explained by the scientist called by the name Eigen. So who explained the concepts of the wave nature? Huygens gives the concepts of the wave nature of light. Now, according to this Huygens, if I considered a source here, now if I disturb this source, the light is going to travel in all possible directions. Light is going to travel in all possible directions. Light is going to travel in all possible directions. Now, if I consider a distance of, let us say, some 3 meters, this particles also reaches 3 meters. 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 So these particles after certain interval of time are vibrating in the same phase. Now you can join all these particles. So after joining all these particles, you are going to get a new geometry. This new geometry is what we called as the wavefront. So on the wavefront, how many particles are you are going to consider? All these particles are going to vibrate in the same phase. That locus is what we call as the wavefront. So please remember, what is wavefront? Wavefront is just a locus. It is just a locus of a point where the particles are going to vibrate in the same phase. Particles are vibrating in the same phase. If any particles start vibrating in the same phase, then whatever the locus you are going to draw, that locus is what we call as the wavefront. That is called as the wavefront. And this wavefront is going to be classified into 3 types. this wavefront is going to be classified into three types. One is called as the spherical wavefront. What is the first one called? Spherical wavefront. Second one is called as the cylindrical wavefront. The third one is called as the plane wavefront. So how many types of wavefronts we have? Three types of wavefronts we have. One is called as the spherical wavefront. Second one is called as the cylindrical wavefront. The third one is called as the plane wavefront. In the spherical wavefront, this will be the source, a point source. This point source is going to produce a spherical wavefront. In the case of a cylindrical wavefront, we have a linear source. This linear source is going to produce a cylindrical wavefront. So which source is going to produce a cylindrical wavefront? Linear source. So point source produces spherical wavefront. Linear source produces a cylindrical wavefront. Plane wavefront is the point source only, but the point source should be placed at infinity. Whatever you are going to get the wavefront, that wavefront is going to be a plane. The wavefront is going to be a plane. So there are three types of wavefronts, Appa. How many types of wavefronts there are? Three types. One is called as the spherical wavefront. Second one is called as the cylindrical wavefront. The third one is called as the plane wavefront. In the spherical wavefront, we are going to place a point source. So which source will produce us a spherical wavefront? A point source is producing a spherical wavefront, and linear source producing a cylindrical wavefront. Linear source produces cylindrical wavefront. Which source is going to produce a plane wavefront? The plane wavefront is going to be produced by the point source. That point source must be placed at infinity. Point source should be placed at infinity. Please remember this. And also you have to remember the logic. In the case of the spherical, whatever the intensity is going to be there, that intensity is directly proportional to 1 by r squared. Or you can tell intensity is inversely proportional to square of the distance. In the cylindrical wavefront, intensity is just inversely proportional to radius, no square. So in the spherical wavefront, intensity is inversely proportional to square of the distance. And in the case of a cylindrical wavefront, intensity is inversely proportional to the distance. But please remember, in the case of a plane wavefront, intensity does not at all depend on the distance. So you can take it as r power 0. R power 0. So intensity is directly proportional to r power 0 or 1 by r power 0. What is the meaning of this? Independent of distance. So intensity does not depend on the distance. It is independent of distance. So in the case of spherical wavefront, how the intensity and distance are related? Inversely proportional to the square of the distance. In the case of a cylindrical wavefront, intensity is inversely proportional to the distance. In the case of a plane wavefront, intensity does not depend on the distance. So please remember, this is the concept how the intensity is going to change in the case of the spherical and cylindrical and the plane wavefront. Then, what exactly this Huygens principle tells now? What is this Huygens principle tells now? Actually, this Huygens principle tells that. What is the principle of that? What is the basic statement of the Huygens then? Now, whenever you consider a source, Because of this disturbance, you got a wavefront. What is this wavefront called? It is the locus of the point where the particles are vibrating in the same phase. For example, if I consider this is the primary source, if this is the primary source, after certain interval of time, if the first particle has reaches a distance of 5 meter, the second particle has to reach by a distance of 5 meter, the third particle also has to reach by a distance of 5 meter. Now, all these three particles are vibrating in the same phase. If all these three particles are vibrating in the same phase, now you can join all these three particles. You can join all these three particles which are going to vibrate in the same phase. This is what we call as a wavefront. This wavefront, we call it as a primary wavefront. What is PWF? Primary wavefront. According to the Huygens principle, these points will act as another source. These points which are on the primary wavefront, this primary wavefront may learn the particles of the particles which are on the primary wavefront. These particles will act as a new source for the next disturbance. It is going to be act as a new source for the next disturbance. So this light would travel in all possible directions. First, I will take it in the forward direction. After certain time, these are the particles which are vibrating in the same phase, right? These are the particles which are vibrating in the same phase. Now, I'm going to join all these new particles over here. These particles also vibrating with the same phase. Whatever the new wavefront we got here, that is called as the secondary wavefront. What is that called? Secondary wavefront. But whenever the disturbance has moved from the primary wavefront, it is not necessary to move only in the forward direction. It may move in the backward direction also. So in the same interval, the particle may reaches here. So these are the particles which may be in the same phase. This also gives a new wavefront. This is also called as a secondary wavefront, because the light can travel in all possible directions. So according to the Huygens principle, what is your conclusion? You have to remember the 2 points. The first one is, whatever the particles are there on the primary wavefront, that will act as a new source for the next disturbance. That next disturbance is what we called as the secondary wavefront. Also, please remember the speed of this secondary wave is same as that of the primary wave. With what speed the primary wave is moving, with the same speed the secondary wave is also going to move. This is what the Huygens principle is going to state. So this is the new wavefront what we are going to get. Any doubt related to this?
No, sir.
Yeah. Now, in the 11th standard, you have studied the concept of the waves. What is the meaning of that waves? Wave is just a sort of disturbance. It is a sort of disturbance which is going to set up in the medium. What is the general equation of the wave? Y is equal to A cos omega t, or also you can take it as A sin omega t also. What is A represents? amplitude. Let us say this is the displacement of the first wave. Let it be the displacement of the second wave as b into cos of omega t plus some extra phase phi. What is that phi? Phi represents the phase difference. Phi represents what? The phase difference. So what are the two equations of the wave? We have considered the two equations of the wave. One is y1 equals to a cos omega t. The second wave we have considered as y2 equals to b cos of omega t plus phi. Now, what I'm going to do, I'm going to superpose these waves. I'm going to superpose this. So if these two waves get superimposed, if these two waves get superimposed, by the principle of the superposition, the resultant wave should be equal to y1 plus y2, isn't it? This is called the principle of superposition. By the principle of superposition, y should be equal to what?
So
y1
y1 plus
y2. If you simplify this, you are going to get another equation, something like r into cos of omega t plus some another phase, let it be some phase phi dash or some theta. What is this r called? R is the resultant amplitude. R is called as the resultant amplitude.
resultant amplitude.
Yeah, this resultant amplitude is equal to root of a squared plus b squared plus 2ab into cos phi, where phi is the phase difference. Where phi is what? The phase difference. So here we have taken both the function as cosine. If this cosine functions, both are cosine function, means both y1 and y2, how they are traveling? y1 and y2 are traveling in same direction. y1 and y2 are traveling in same direction. When these two waves get superimposed, if the two waves which are traveling in the same direction get superimposed, this results in the formation of interference. This results in the formation of what? Interference. So in order to get interference, minimum how many light waves we require? 2 light waves we require. In which direction the 2 light waves should move? Those 2 light waves must move in the same direction. 2 light waves has to move in the same direction. And if they get superimposed, that results in the formation of what? Interference. For example, you consider the graphical representation so that you can understand better. If I say the first wave is moving like this, now what is the amplitude of this? A. This is the amplitude of A, like this. Correct? Now I'm going to consider the second wave. The second wave is also moving in the same direction but with lesser amplitude. The red color one is the second wave which is moving. Got it? What is the amplitude of the second wave? Let it be B. Now if you superimpose this wave, you should get what? you should get resultant wave. That resultant wave will be like this. So one thing you can notice in the resultant wave, the amplitude is more than this, right? A plus B, correct? No?
Yes, sir.
Yeah. But in the second wave, I'm going to consider like this. This is the first wave. This is the amplitude A. Now I'm going to consider the second wave, which is moving in the opposite direction like this. The waves are in the opposite direction. So the second amplitude will be downward, B. Now, if I club these two waves, I should get the resultant wave, right? That resultant will be like this. The amplitude is less. That amplitude will be the A minus B. So look at the difference. Look at the difference. In the first graph, the crest of the first wave falls on the crest of the other. Trough of the first wave and the trough of the second wave falls on the same thing. But in the second case, crest is going to fall on trough. Trough is going to fall on crest, like that, alternate. So if crest falls on crest, amplitude will be more. If amplitude is more, intensity will be more. In the second case, the amplitude will be less if crest falls on the trough or trough falls on the crest, and intensity also going to be less. So based on this, please remember, we have classified the interference into two types. We have classified the interference into how many types?
Two types, sir.
Based on the amplitude and the intensity. One is called as the constructive interference. The second one is called as what? Destructive interference. So how many interferences we have? Two types.
So two types, sir, constructive and destructive.
Constructive interference and destructive interference. Please remember, in the case of a constructive interference, phase must be always equal to 2n pi. What must be the phase difference for constructive interference? 2n pi. Path difference x must be equal to n lambda, where lambda is the wavelength. So what must be the phase difference for constructive interference? It should be equal to 2n pi, when n starts from 0, 1, 2, 3 like that. So what is the condition for the constructive interference? For the constructive interference, phase difference must be equal to 2n pi and path difference must be equal to n lambda. For destructive interference, phase difference must be equal to 2n plus 1 into pi and path difference must be equal to 2n plus 1 into lambda by 2. So please remember, what is the condition for the phase difference and path difference for constructive and destructive interference? For constructive interference, phase difference must be equal to what? 2n pi. Path difference must be equal to n lambda. For destructive interference, what must be the phase difference? 2n plus 1 into pi, and path difference must be equal to 2n plus 1 into lambda by 2. Please remember, in the case of a constructive interference, the resultant amplitude should increase. In the case of a destructive interference, the resultant amplitude should decrease. So you have to remember these conditions while solving the problems. It is going to be very helpful. Now, one more important thing. In any case of the interference, how intensity is related? Intensity is directly related to square of the amplitude. How intensity of the wave related to amplitude? Intensity is directly proportional to square of the amplitude. Now, let me analyze one by one. If two amplitudes are A and B and the phase angle is phi, what is A and B? A and B are the two amplitudes. What is phi? Phi represents the phase. Phi represents the phase. Now, if these two get superimposed, the resultant amplitude will be equal to root of A squared plus B squared plus 2AB into cos phi. What is the resultant amplitude formula? When two waves get superimposed, what is the resultant amplitude? Root of A squared plus B squared plus 2AB into cos phi. Now, for constructive interference, you know that the phase angle should go with the 2n pi, like 0, 2 pi, 4 pi, like that. It should go like 2n pi. If I take the phi values as 0, cos 0 value will be 1, cos 2 pi value 1, cos 4 pi value 1, cos 2n pi value 1. So this implies what, Appa? Cos 0, cos 2 pi, cos 4 pi, any cos value of this is equal to 1, right?
1, sir.
If that cos phi value is equal to 1, what happens to the formula? What is the left out term?
Sir, root of A square plus B square plus 2AB.
That can be taken as R is equal to A plus B, isn't it?
Yes, sir.
So this itself represents the maximum amplitude. So what is the R max value? Maximum amplitude is given by R max is equal to A plus B. If you want to get a minimum amplitude, then you have to consider what type of interference.
Sir, destructive.
So in destructive interference, you know that the amplitude will decreases. So in the destructive interference, you know the value of phi? It should be like pi, 3 pi, 5 pi, like this. Last number should be 2n plus 1 into pi. So you can find what is the resultant amplitude here. Cos pi, cos 3 pi, cos 5 pi, cos of any odd number pi is minus 1, no?
Yes, sir.
So if I take cos phi as minus 1, what happens to the formula? A squared plus B squared minus 2AB.
So minus 2AB, sir. So the R is
what is
equal
the
to A
amplitude
minus
here?
B. A minus B, sir.
A minus B. This is the minimum amplitude. So maximum amplitude will be A plus B. Minimum amplitude will be A minus B. Now, can you calculate what is R max divided by R minimum? What is the maximum amplitude resultant one? A plus B. Minimum is
A
A
minus
minus.
B, sir.
So maximum amplitude will be A plus B. Minimum amplitude will be A minus B. This is how we are going to solve in the case of constructive and destructive interference. Now, Patapat, can you tell me for intensities? Can you tell me for intensities? What is intensity formula? It is I1 plus I2 because intensity is square of the amplitude, right? So A squared can be taken as I1, B squared can be taken as I2. I will keep 2 as it is. A squared is I1, so A will be root I1. Root I1, root I2 into cos phi. If you don't want this root, will you do the squaring on both the sides, so it becomes R squared. So R squared will become I. So what is the formula in terms of intensity? It is I1 plus I2 plus 2 times of root I1 I2 into cos phi. Can you tell me what is I maximum and I minimum? I max by I minimum. It is square of the R max by
So
R
R
minimum,
max by R minimum.
square of the amplitude. What is R max by R minimum?
So
So
A plus B by A minus B,
A plus B by A minus B,
the whole square, sir.
the whole square. Or A can be taken as root I1, B can be taken as root I2, A can be taken as root I1, B can be taken as root I2, whole square. So this is the ratio of the maximum intensity to the minimum intensity. Any doubt related to this amplitude and the intensity?
No, sir.
Okay. Now, suppose if I give A is equal to B, A is equal to B, both the amplitudes are same. Can you tell me the general formula for I? General formula for I? Or first you can tell me for the amplitude. First tell me for the amplitude only. If A equals to B, what will be R?
So,
Simplify.
sir, is it infinity, sir? Because A minus B is 0.
Why it will come to infinity? For example, you consider this as the equation 1. Now I am asking what will be the value of R? A equals to B. Wave amplitude of the first wave and amplitude of the second wave are equal, I am asking.
Yes, sir, once more.
How come it will be infinity? No, you substitute in the equation 1. In the equation 1, just you equate A and B are equal. You just substitute B equals to A.
So 2A, sir. So
What
2A
equals
or
to cos
2B?
phi?
So 2A or 2B cos pi, sir.
No.
So cos,
You can tell 2a only in the case of constructive interference.
yes, sir.
Only in the case of constructive interference, you can tell 2a. If it is
Yes, sir.
destructive interference,
So then 2B, sir.
zero. For
I mean
destructive
0, sir.
interference,
Yes,
a
sir.
minus
Because,
b, no.
yes, sir. A minus B is 0, sir.
Ah,
Yes, sir.
but now I'm not asking you either in constructive interference or not in destructive interference. I'm asking you general formula. I'm asking you general formula.
Yes, sir. So cos pi is 1, right, sir?
Why? How can you tell cos phi is 1?
So like without considering without even considering that it's constructive or destructive, sir.
No, you can't take like that because cos phi value may varies from +1 to -1. If it is constructive interference, you can take it as 1. So you have to do what? Just substitute in that formula. Tell me what will happen. Root of
So a square plus a square
ah,
plus 2a square
ah.
cos pi, sir.
Okay, good.
Sir, I'll give root of 2a square plus 2a square cos pi.
Okay, good boy. A square plus a square, 2a square plus 2a square cos phi, right?
Yes, sir.
Yeah. So R equals to root of 2a square. I will take out common. It will be 1 plus cos phi, right?
Yes, sir.
Now R equals to root of 2a squared as it is. You know off angle formula for 1 plus cos phi?
So 2 cos square 5 by 2, sir.
Yeah, please remember that off angle formula. So this will be equal to root of 4a square.
So 4a square cos square 5 by 2, sir.
Yeah. If I take root of that,
So 2a cos 5 by 2.
so remember this formula. If two amplitudes are equal, directly you can write the resultant amplitude. What is the resultant amplitude?
So 2a cos 5 by 2.
R equals to 2a cos phi by 2. This is the resultant amplitude. If you know the resultant amplitude, can't you write intensity?
Yes, sir.
Intensity is nothing but square of the amplitude. So you just do the square of the amplitude. It just becomes 4a square. Cos phi by 2. Clear?
Yes, sir.
Yeah. This is very important formula. This resultant amplitude, the intensity. The intensity is 4a square cos phi by 2. And resultant amplitude is 2a cos phi by 2. Yeah. If it is exactly constructive interference, if you take phase angle as 0, now you will get the same thing. What you said, like 2a and all those things, you said no. If phi is equal to 0, cos 0 value will be 1, no.
Yes, sir.
So you will get 2a automatically. So generally we are not deriving the formula for constructive or destructive. We are getting the formula for general case. which holds good for both constructive interference as well as for destructive interference. So that is for any type of wave, resultant amplitude is 2a cos pi by 2 only if the amplitudes are equal.
Equal, sir.
Yeah. Usually, I will give one few examples to understand better. Now, the two waves are moving in the same direction. The two waves are moving in the same direction. So what is the phase angle? 0. Now the first wave is moving like this. The second wave started here. The phase difference between the first and the second particle is 60 degree. Is how much? 60 degree. I want the intensity in this is I1. The intensity in this is I2. I will tell the amplitude of both the waves are same. Here also the amplitude of the two waves are same. Can you tell me what is I1 by I2, Appa? Can you tell me the ratio I1 by I2? Fatapat. Tell me if the amplitudes are same. If amplitudes are same, what is the formula for intensity, Appa?
So 4a square cos square 5 by 2, sir. Just
Yeah, you just substitute I1 by I2, no?
yes, sir. Yes, sir.
I1 will be 4a squared only, I think. Because phase angle is 0, right?
Yes, sir.
Divided by. What about I2? Four a squared will be as it is. Cos squared 5 by 2,
So
right?
cos square 5 by 2, sir.
60 by 2, no?
Yes, sir. 30, sir.
Yeah. So what is I1 by I2? This 2 will
So
get
4a
cancelled.
square 4a square cancel, sir.
Cos
So
30. Cos 30 is root 3 by 2. Square of that.
So 3 by 4, sir. So 4 by 3.
So what must be the ratio of the intensity?
4 by 3, sir.
4 by 3. Yeah. Now, I'll give second example. I will give the intensity of the first wave as 9. Intensity of the second wave as 2. Can you tell me I maximum by I minimum? You know that intensity is directly proportional to square of the amplitude, no?
Yes, sir.
Yeah. If intensity is directly proportional to square of the amplitude, what is the amplitude of the first wave? 3.
Yes, sir.
Because A is directly proportional to root I. You just
Yes,
take
sir.
the root 9. That gives the amplitude.
Yes, sir. 3, sir.
Similarly, what? You make it as 4. You make it as I2 as 4.
Sir, then B
Can-
will be
Can you
root
tell me
of
the
4,
amplitude
2,
of the
sir.
second wave?
2, sir.
2. Yeah. I've given one formula for I max to I minimum U. It is just A plus B divided by A minus B.
Yes, sir.
Whole square, no?
Whole square, sir. Yes, sir.
What is A plus B?
So 5 and A minus B is 1.
So it is 25:1, right?
Yes, sir.
So this is how the problem may be asked by giving the intensity, amplitude, phase angle and everything. Now, one more concept. Now, I will give a convex lens to you. Just I am giving a convex lens to you. Okay. Now, I will incident a paraxial ray here. This is the first ray. This is the second ray. This is the third ray. Can you write the wavefront for this? Can you write the wavefront for this? Yeah, can you tell me? Okay, at least can you tell me among these 1, 2, 3, 1, 2, 3, which ray is going to be incident the lens first?
Sir, 2, sir.
Very good. This is going to be incident first. So this will enter. As soon it enters the lens, its speed will decreases, right?
Yes, sir.
Yeah. After certain interval of time, the first ray and the third ray will incident and it will come out fast. It will come out fast. The first ray already reaches this point A. The third ray already reaches the point B. But second ray is lagging now. Will you agree for this?
Yes, sir.
The second ray is still lagging. Why it is lagging? Reason is, actually the second ray is incident first, but that second ray has to travel large distance inside the lens. When it has to travel large distance inside the lens with less speed, it will take more time not to come out. It will take more time not to come out.
Yes, sir.
But the first ray and the third ray incident to the lens is delayed. But it is not traveling too much distance inside the lens, so it will come fast. So A and B will be leading, but the C is going to lag. Now you can join all this A, C, B. So whatever A, C, B you are joining here, this gives the wavefront. This
Yes,
gives
sir.
the wavefront.
Yes, sir.
Yeah. They may be asked upon to write the which is the correct wavefront for convex lens. They may be give the 4 options. They may be give the 4 options like this. Yeah. Last one. Can you try it for prism? Can you try it for prism? Can you try it for prism?
Yes, sir. Sir, the incident light ray, sir.
You can mention this is, sorry. This is the first ray. This is the second ray. This is the third ray. 1, 2, 3. Can you tell me which ray will be incident first?
Sir, 3, sir.
3. Yeah. After third ray incidenting on that, it should undergo what? Refraction. in that refraction it has to travel larger distance, right?
Yes, sir.
Then second one little bit less distance. First one
Yes,
will
sir.
incident late, delay.
Yes, sir.
Third ray, second ray is incident first, but the first ray is delayed. But it will come fast, no, from the prism.
Yes, sir.
Why? Lesser thickness
because-
inside the prism.
Yes, sir. Yes, sir.
Then the second one is going to lead. Then the third one is going to lead like this. So the
Yes,
first
sir.
particle travel larger distance. Now you join all these things. You join all these things. This gives the new wavefront.
Yes, sir.
So this is how the wavefront is going to act in the case of prism. So this is how we are going to write the wavefronts apart. So they may be asked to draw the wavefront for lens, for prism, or even for mirror also they may be asked, okay? So depending upon the options, you have to tell which is right and which is wrong. Any doubts?
No, sir.
Okay. So this is the concept of the superposition of the two waves, and we have analyzed the concept of two interference, that is constructive and the destructive. We have studied three concepts today actually. One is Eigen's principle. The second one is interference. The third one is the types of interference, that is constructive and destructive. And we have analyzed what is the amplitude and the intensity of the constructive and destructive interference. So in the next class, I will take up the concept of interference, diffraction, and polarization. After analyzing this interference, diffraction, polarization, we can solve a problems. But this is not a lengthy chapter like ray optics. We can finish it early only. Okay.
Yes, sir.
Okay, pa. I will stop at this stage. We'll continue in the tomorrow session. Thank you.
Thank you, sir.
ನೋಡ್ದಾ ನಾನೇ ಹೆಂಗ್ ಒಬ್ನೇ ಬರ್ದೆ ನೋಡ್ದಾ ನಿನ್ ಇದು ನಾನು ಹೆಂಗ್ ಒಬ್ನೇ ಬರ್ದೆ ನಾನ್ ಬಡಿತಾ ಇದ್ದೆ ನಾನ್ ಬಡಿತೀನಿ